There you go. So I want to already give you a heads up. I always try to first write out what my plan is. I don't jump into my formulas right away. Because if you tell yourself what needs to be done and then use your formulas, you're less likely to miss one of the shapes. Sure, down the road on a test or whatever, my key may not do that anymore, but for now. So I want you to, for example, if I just flip through some of the questions I assigned, right? On page 21, there's this one I'm going to ask you to attempt yet. There's this one, which is basically a rectangular prism with a triangular prism hole through it. And so when it comes to surface area, if you were to go inside, right, the hole, then you could look at those three faces that make up that shape, and those rectangles in there also have to be included for your surface area. I'm gonna try. I have some. I designed some 3D shapes using a software, so then we can actually like zoom into certain areas. It's easier to see what we're doing. So let's go to page 15 for now, and I'm just gonna give this one a try. Okay. Maybe I will first ask you to look at it. If you had to find out, let's do the surface area first, then we'll do the volume next. But if you look at this, how would you even approach it? Like, you don't have to write anything yet, just look at it. And how would you go about finding? All right, ready to go? You thought about it? Maybe you're just like, I don't know, I'm wondering what I'm going to have for lunch, right? That's what some of you were thinking. So here we go. This is my approach. We don't have a formula for this shape right here. We don't, okay? So we need to kind of look at the large one, the large cone, and then there's this small cone. You see that? The one that's like chopped off. So I'm gonna go with minuses here. I'm gonna subtract things. So total surface area, the way I'm gonna do that, I'm gonna go surface area of the large cone. Right, I'm going to take the big one, including the dashed line. I'm going to go minus. Here you have to be careful. Wording is key. I'm going to then take away this part right here. But I'm going to leave. So you got to imagine that small cone, right? I'm talking about that one. I want to leave the base of that cone there because it's going to be part of what I want. Okay? That's exposed. So I'm going to subtract just the lateral surface area of that cone, of the small one. Does that ring a bell, lateral surface area? LSA of the small cone. Are we good there? So let me use some highlighters here. So this is the large cone right here. If I find a surface area of that, right, then that would be in the entire shape right there. Then I'm going to go ahead and take away the lateral surface area, like this one here. Right? Just that is this. But this would still leave with a problem. If I take away this pink part, I still need to, I don't know if you, let's see if you can agree with me, I still need to include this. I still need to add this to the mix. So I'm going to go plus small circle. Okay, so that's this one. And I want to maybe I'll put myself in your shoes. Well, if you took away this one, the lateral surface area, like this piece, aren't you leaving this behind? But technically it was never included in the first place. We just found the surface area of that big one. That includes this, right? That's taken care of. Then we take away just the lateral surface area, just this cap, but yet we need to include this, so we need to add the small circle. Is this the only way to do this? No. I can tell already, as some of you will work through these, you will find another way of doing it. Absolutely fine with it. There's nothing wrong with it. Okay? So let's go ahead and plug in some formulas here. Before I do so, this is the diameter, right? You're going to need the radius, so let's go ahead and find the radius already. .625, I'm not going to round. And then this one here, this is the diameter. So the radius of the small one is just 0.5 of an inch. So let's get that out of the way. If it's a cylinder or a cone, anything like that, if it's a sphere, you're probably better off finding the radius right away. Okay, so let's go ahead and plug this in. So total surface area, let's just do formulas. Let's just not jump the gun just yet. So surface area of the large cone, I would go pi, I'm going to go capital R, pi r squared plus pi rs, okay? So that's the large cone, minus the lateral surface area of that small cone, that is just pi rs. Right? If you just want the lateral, that's pi rs. Plus the small circle, that's pi radius squared. Maybe let's go back up and differentiate, like capital R, lowercase r. So this one up here, let's make that a capital R. It's just easier. And this is our lowercase. That way we distinguish between the two radii, right? Okay, plug in numbers and go. So total surface area is pi 1.625 squared plus pi 1.625 times the slant. Let's see if we have the slant. Do we have the slant of the big one here? We actually do. So let's call that capital S, right? So I'm going to use the slant of the big cone. It's already given, so not a big deal. So this first square bracket is done there. Whether or not you like the square bracket idea, that's up to you. You can, whatever works for you. So pi r, the radius of the small one, because we're now looking at the small cone, we're using 0.5. And the slant, do we know the slant of the small cone? Not yet. Not yet, right? We can find this. This is slant small, right? We go 7.85 minus 4.32. We subtract this from the long one, so that is 3.53 inches. Okay. And the examples I give you have a lot of moving pieces, just because I'm trying to cover a lot of ground here, different scenarios that you may encounter. So this is the lowercase s. I'm going to use that here. Right? And then plus the pi r squared. I'm just going to go pi and then 0.5 squared. So the challenge now is to make sure you get the calculations right. So let's see here. I would break it down a little bit at least, just to be safe. So let's see here, pi times 1.625 squared plus pi times 1.625 times 7.85. All right, do that square bracket. So that's 48.37 something, right? Minus, I will do this part, pi times 0.5 times 3.53. That's 5.54 something. And then I'll just do that other piece, which is, and you might think, right, if you think about it, you won't be off by a whole lot if you forget to add the little circle. You won't be up by a whole lot, but it's the process. That's why you need to show me the work, right? So now we add and subtract as needed. So I'm going to go plus that minus that plus that, and you get 4361. Yeah. Square inches. So that's the total surface area for that truncated cone. All right, now total volume. I'm going to cut this here. TV. I guess this is just volume of large minus volume of small. That's really all that there's to it. Total volume. The formula for volume, it's pi r squared. I guess we'll have a capital H divided by 3 minus pi radius squared lowercase h divided by 3. Do we know the height of this thing? We don't. So Pythagorean theorem is usually involved, quite often involved in these. So I'm going to do the large one here. Let's see. So if I take the large one, this is large. I know that the radius is 1.625. I know that this is 7.85. And this is capital H right there. So I don't know if you remember, but if you just want one of the legs, right, you just take the hypotenuse, square it, and then subtract one of the other legs from it. That's basically all that there's to it. And I'm a big fan of just leaving it in a root. So I'm going to go 7.85 squared minus 1.625 squared. So if you need the hypotenuse, then just square and add the legs. If you have the hypotenuse and you need one of the legs, just subtract, right? Go hypotenuse minus the legs, just make sure you square. And so you get that. Root of 5898. You know what? This is a bit, if it's not a whole number, I actually will just find the answer. So I'm going to root it. 7.67 and so forth. So let's just keep it like that. We know that it's in our calculator. We can go get it anytime. Let's do the same with the small cone. So I'm going to cut this here. This is the smaller one. I want the height. I know the radius is 0.5. I already know that the slant is 3.8, oh, sorry, 53, yeah. And the process is the same here. Take the root of the hypotenuse squared minus the other leg squared. .53 squared. There you go. Take the root of that. Oh, let's first write this in. 12.21. 3.49, and that keeps going inches. A lot of work for that, but if you know what you're doing, it actually doesn't take very long. You wouldn't even need to give me that little diagram there. Like I prefer it. I always like to have a visual, right? But there we go. So now let's plug it in here and complete this, the total volume. So it's pi radius of the large one squared times the height of the 7.67 dot 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 divided by 3. Oops, I'm gonna be tight space here, but I'm gonna make it work. Squared, don't forget the square, and then it's 3.49 dot 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 divided by 3. Okay, so here we go. I need to go find that height. There it is. Just plug it in. Divide by 3. And then let's do this all over again. I'm going to go find that 3.49 there. Divided by 3. Don't forget that. And here we go. Just take 21 minus 0.29. Anybody catch a mistake? Doesn't quite match my key. Oops. Heights are good. Everything is good. Okay, I'm going to investigate. Feel like I squared this radius. Yeah, this is good. Did I square? Yeah, I got that, divided it by 3. Okay, we're good. So then I can now say that my answer is 20.32, and we're in cubic inches. Just like that. Fun, eh? If you ever do renos or projects, or you're working for a company and they have like different challenges like this, if you know how to do this, you'll stand out. Trust me. Yeah. You get full marks minus half a mark for rounding. The way the exam is marked, should probably not put this on the video. It's all right. So we've got total surface area, total volume. Chances that I'm going to ask you for both are probably slim because it's so much work. There's so much that can go wrong, and so marking would be quite difficult. I'm going to ask you to try I'm interested in, maybe I should take it one step at a time. I'm interested in 4 and 5 here. If you did it for homework, way to go. I want you to keep doing that. But I'm gonna explain this concept. Okay. Volume of prism is the area of its base times the height of that shape. And so for most of the shapes, you just have the volumes. Like this is just what it is, right? But if you think about it, a cylinder, yikes, that's not a good cylinder. But we know that the area of the base is pi r squared. This is on page 18. We know that the area of the base is pi r squared, and we multiply that by the height, so the volume is pi r squared h. Okay. We have a rectangular prism. Yeah, I know I'm not really good at sketching these, so pardon my art. Okay, so the area of the base is length times width, and there's your height. So the volume of this would be length times width times height. You just don't think of it. You just probably just memorize it, right? And just like, hey, this is what it is. Then there is the one you were exposed to earlier. And if you want this formula, I will give you that formula, right? I just don't know the best way to sketch it. So you're going to have to copy this at your own risk. So I'm just going to go there and replicate that triangle. Okay, not bad, not bad. The area of the base is base times height divided by 2. And then you multiply it by the other height, which is, I will call that capital H. Okay, so volume is base times height divided by 2 times capital H. It doesn't get uglier than this. This is about as ugly as it gets when it comes to volume. Hey, it has to be a prism that has the same base throughout. Like you could literally stack the base and get that same shape. A cone doesn't work, right? We divide it by 3. A pyramid wouldn't work because it points, right? So it doesn't work. It has to be one of these here. So if you had, Valentine's Day is over already, right? But if you had a heart-shaped prism, right? This is, I don't know, this is not going to work very well, but hey, right? If you knew a heart prism, right? So if you knew the area of this shape, I could give you, hey, the area of this heart is, I don't know, 50 centimeters squared. And you knew the height of this prism, you could just take that area, multiply it by the height, boom, you've got the volume of it, right? So, question mark. Right? I have no idea. So just that property keeps going. Why did he pick a heart, right? I don't know. I was thinking of my wife. Maybe that's what it is. Anyway, so there we go. So this property, we're going to take it with us when we do the one that some of you were kind of frustrated with. That's okay. So let's go to page 20, question 5. It turns out that I don't have the surface area in my key. So here it is. So total surface area, page 20, question 5. 5. So we want the surface area of the box. Oh, we're going to run out of time. That's what's going to happen. So That's what happens when I talk too much. So I'm going to say this one more time. I know that we're pressed when it comes to time. We only have so much to go around, but I need you to try, if you haven't done these two, actually, I'm going to take it back. You may have done this with your classmates on the whiteboard. I would still say try these two questions by yourself, as well as page 21, which has a whole nother challenge to it. Okay? So, and then tomorrow, you can expect an AC on this type of scenario. If I have time, maybe I'll look up an old video where I actually solved this. So if you're really stuck, like stuck beyond repair, right? I will try to have that video up. If I have time, I'll try to make one, and then you just get unstuck that way. Okay? Thank you guys. Appreciate your cooperation.